Welcome, salutations. This is lesson 2.2e, deriving the equations of y equals mx and y equals mx plus b. Remember, we've been talking about proportional relationships and linear non-proportional relationships. Today it's important that you have a ruler with you and at least two different colors or a pen and a pencil. Let's get started. Number 1, use the coordinate plane below to complete the given instructions. Let's read our instructions first together. Graph a line in the coordinate plane that goes through the origin and has a slope of 2/3. Label the rise and run on your graph with a right triangle. Redraw and label your triangle in the space provided below the graph. Let's break down these directions to see what we need to do first. The first we need to do is graph a line that goes through the origin and has a slope of 2/3. Let's do that first. So if I have a slope of 2/3, I don't want you starting to draw any numbers on here. Just think 2/3. Remember, slope, which is little m, is rise over, that's right, rise over run. So when I look at 2/3, should the rise be greater than the run, or should the rise be less than the run? The rise should be less than the run, and then this line should be increasing from left to right because we have a positive slope. So maybe it looks something like this. And let's draw our line so it goes across the entire coordinate plane, and of course we're going to put arrows on the end of our line. So this line goes through the origin, is an increasing line, and has a slope of about 2/3. The next thing we need to do is label the rise and run on our graph with a right triangle. To do this, let's start at the origin, go up, and over to our line. Because we know we have a slope of 2/3, which is rise over run, let's put that right here, 2/3. We know that the rise of our right triangle is 2, and the run of our right triangle is 3. Label the rise and run on the graph with your right triangle. Redraw and label your triangle in the space provided below the graph. So down here, I'm going to draw my first right triangle, which is my green right triangle, and that has a rise of 2 and a run of 3. Part B. Does this line describe a proportional relationship? Explain why or why not. Because it's talking about the line, make sure you use vocabulary that has to do with the graph. Is this a proportional relationship? Yes. The graph is linear and includes the origin. Wonderful. Let's read Part C. Part C says choose any point x, y on your line and draw a right triangle that describes the rise and run. Redraw and label your triangle below the graph. So I need to choose any point x, y on my line. Literally any point x, y on my line. Because I need to do some labels, I'm not going to pick a point that's in between my triangle right here. I don't need my notes to be any messier than they usually are. So let's put, stop! Let's go right there. And I'm going to label that point x, comma, y. Remember, this point's x, y because this x value and this y value. Awesome, let's see. Now it wants me to draw a right triangle that describes the rise and the run. Well, if I'm making a right triangle with my graph, I am going to go from the origin again and go up and over. And I'm going to label the rise and the run. Well, the rise is here from the origin to this point. Do you remember how I can determine what this point is? Go back to this coordinate, and the y value is this vertical distance. So from here to here is y. That means from here to here is the same distance from my origin to my x value, which means my run is x. Then I need to redraw and label my triangle below my graph. So I'm going to redraw, and my new triangle is a little bit larger than my green triangle. I'm going to draw it in the same orientation. Probably should show that these are right triangles. Okay. Redraw and label your triangle. Done. Let's look at part D. Write a proportional equation with your ratios. Explain why the ratios can be set equal to each other. Looking at these two triangles, because they are dilations of each other, which make similar figures, our corresponding side lengths are proportional. So explain why the ratios can be set equal to each other. Triangles are dilations, which means they are similar, which means that corresponding side lengths are proportional. Remember, all proportional means is that they have equal ratios. Because both these triangles are determining the slope of a line, and lines have constant slope, we know that these ratios are equal, and that's what proportional means. Proportional means equal ratios. So we're going to write a proportional equation with our ratios. Remember, because these triangles represent slope, rise over run, we can have the rise and the run of our one triangle equal to the rise and the run of our similar triangle. So that means 2 is to 3 as y is to x. Awesome job. 2 is to 3 as y is to x. Or we could say that 2 corresponds to y as 3 corresponds to x, just like our other similar figures we looked at before. Now we need to solve our equation that we wrote above for y. When we solve proportions, we use cross products, and you've been doing a really great job this module solving proportions. Since we're solving for y, I'm going to put my y term on the left. 3y equals 2x. To get y by itself, I need to divide both sides by 3, and I end up with my equation y equals 2/3 x. And this is a really important equation. Where do you see the slope in the equation? Well, the slope was 2/3. 2/3 is the number being multiplied by x. With equation, the right vocab word we want to use is, that's right, coefficient. The slope, 2/3, is the coefficient in the equation. Coefficient of x in the equation. Always read what you write. So you say what you mean what you say, and don't say it mean. Does your equation represent a proportional relationship? Justify your reasoning. Remember, proportional relationships relate x to y through only multiplication. So we can say, is this a proportional relationship based on the equation? Yes. X is related to y only through multiplication. You can call 2/3 your constant proportionality or also your unit rate. Really nice work. Okay, now we're going to do the same construction of deriving an equation of a line that goes to the origin, but we're going to not be given the slope anymore, and we're going to replace that with the variable m. So please turn the page and let's look at number 2 together. Number 2 says use the coordinate plane to the right to complete the given instructions. Part A. Graph a line in the coordinate plane that goes through the origin and has a slope of m, where change in y values over change in y values is m and change in x values is 1. Label the rise and run on your graph with a right triangle. Redraw and label the triangle in the space provided below the graph. So what they're saying here is that because we know that slope is little m, which is rise over run, to make our calculations easier and more efficient, we're going to say that this is m over 1. Since we always want to represent slope as a simplified ratio, if there's a number without a denominator, that sneaky silent denominator is always 1. So again, let's make sure you have a ruler for this construction. First thing we need to do is graph a line in the coordinate plane that goes through the origin and has a slope of m. We're going to take the slope of m to be positive to be similar to our last construction. However, this time you can make it as steep or as less steep as you'd like. I'm going to make mine a little bit steeper than I did last time. Make sure you go completely through the origin and include lines on the ends of your arrows. Awesome. Now I'm going to take my line and I'm going to label the rise and run on my graph with a right triangle. I'm going to start at the origin. You always want to start at your y-intercept, and for this relationship, this proportional relationship, we want to start at the origin because that's our y-intercept. I'm going to make my right triangle with endpoints on my line, the hypotenuse as my line, and the rise is going to be m, and the run is going to be 1. Redraw and label this triangle in the space provided. So again, I'm going to draw my right triangle, a rise of m and a run of 1, a change in y values of m and a change in x values of 1. Does this line represent a proportional relationship? Yes. Explain why or why not. Yes, the graph is linear and includes the origin. The relationship has a constant rate of change and includes the origin. Please make sure to have that written on your paper. Now we're going to choose any point x, y on your graph and draw a right triangle that describes the rise and run. So again, it doesn't matter which point you choose. You probably want to pick one a little bit higher up so that we can avoid writing over our right triangle. So I'm going to pick one up here. I'm going to label this x, y, an ordered pair. And it's that order because it's alphabetical order. So taking a look here, I now need to create a right triangle. Again, I'm going to go straight over to my y-axis and then down to my y-intercept, the origin, and I'm going to label the rise as the vertical change from 0 to this point here. If I go across, I notice that's going to be the same as the y value. So if I had gone up 3, this y value would be 3. So I'm going to label this distance as 3. And, oops, sorry, as y. I'm going to label this distance as y. And this distance, my run, my change in horizontal position from here to here is the same distance. And that I'm going to label as x. And I'm going to redraw label my triangle below. So this triangle is slightly larger, but of course it's still a right triangle. These triangles are dilations of each other, which makes similar figures, meaning that the corresponding line segments are proportional to each other. Proportional means the ratios are equal. So now I need to write a proportional equation with my ratios. what corresponds to what? The height